Hello, my name is Alan Richardson and I want to talk about adding more security into your testing and automating. And if you want to find out more about me, you can look at eviltester.com or find me on social networks as @eviltester. Now, one of the interesting things for me is that security testing is incredibly interesting. It's just not the fastest way of adding more security type concerns into our process. I mean, security testing, I've spent, I don't know how many years learning security testing. It's a highly technical set of skills, highly set of technical knowledge. We have to understand the technology. There's a massive wide domain of things to cover in terms of social engineering, how we use the tools, risks in applications, low-level coding issues. There's always new vulnerabilities being found and there's new case studies. And it takes a long time to learn and practice, as does testing, as does programming. So we already have this wide range of things we're trying to learn. So do we really want to add security testing on there as well? Now, I'm not trying to put anyone off security testing because I've really enjoyed learning it, but there are ways of doing this faster. Of course there are. And the easiest ways of introducing anything new in our process is to find out where it overlaps with what we already do, how to extend what we do naturally to cover those overlaps, and how to augment and add new tools in that can help us with our current approach but can extend across into this other way of doing things. Now, I'm absolutely definitely not trying to put anyone off trying to learn security testing. Right? I've loved learning security testing. It just isn't the fastest way to add this into our process. Right? I find security testing enormously interesting. I've taken part in bug bounties and found bugs in live systems. Most of the security bugs I have found in live systems, unfortunately, were in systems that don't have bug bounties, so I wasn't paid for it. But the challenge of finding new things, spotting these avenues of approach is enormously interesting to me because I love the technology that we're working with and I love learning more about that technology, but that's not for everyone. But every process, given some caveats, can extend their security testing more easily. I have a slight advantage because I know how to test, I know how to program, I know how to automate. I've been doing this for a long time, so I can see the natural overlap in extensions. Some of you will be early on in your career. Adding more security testing in there at this point may not be the best use of your time. I've been doing this for so long that adding security testing on at the end is just an extra thing, another set of level of knowledge to build on. Being able to spot the overlaps means I can now tell you some of the places where we can add extensions. So if you are already doing technical exploratory testing, some of these toolings that we're about to mention are a natural extension to what you're doing. So if you're already using the dev tools, if you're already looking at the HTTP messages that are being sent, if you're already aware of the structure of your application in terms of HTML and JavaScript and where the CSS fits in. If you're already using proxies to look at the HTTP messages and replay them back, perhaps using some of these security tools to already do fuzzing, but not necessarily for security, just to help you with your testing. If you're already looking at the application from a technical level and looking at it in terms of, well, no, I can see the potential for bypassing the validation here and not using the GUI, but instead hitting the HTTP messages directly. If you're looking in the application for edge cases that are there in the code or there in the way that we handle the technology, everything that we're talking is a natural extension for you. If you are already automating in a very controlled, you might call it advanced, but technical fashion, where you're writing reusable abstraction layers, which means you might be using the abstraction layers to support your ad hoc exploratory testing, possibly combining it in your performance testing, having gherkin layers on top for data-driven type approaches, but reusing abstraction layers that you're also using in direct test control frameworks like JUnit or TestNG or whatever. If you have this very architected and structured way of working, then adding in additional tooling is going to be very easy and natural for you. If you're already combining libraries and tools, so you've got WebDriver and HTTP libraries and possibly some REST API libraries, and you're using them for specific reasons because you understand the technology that they cover. If you already have the abstraction between paths and data, where you're parameterizing the data that's coming in to specific paths, possibly using Gherkin to do that, you can easily build on that to add in more security concerns. And particularly if you're automatically generating the test data, then some of this work isn't going to be natural to you. If you've extended it into monitoring all the logs, I mean, basically, if you have architected a automation approach that doesn't just rely on one tool, one approach. So since I don't want to put anyone off learning security testing, because you will still need to understand some security testing knowledge as you do this. Otherwise, any results you get back from adding more tools will not help you. So there are a massive amount of books that you can read about this. But if you already know the technology, if you already know HTML, JavaScript, you already know how HTTP works, if you already are using some of the tools, HTTP proxies, then security testing is simply an extension to that, right? You learn the vulnerabilities, you learn the associated vulnerabilities that with the languages and libraries that you're using, you learn how people exploit the technology they're using. You don't have to learn from complete scratch, right? Because you already have a lot of this knowledge from your testing. So I'm not going to cover in detail how to learn security testing because all that information is out there. There are so many roadmaps and learning paths out there on the web that you can have a look at. The slides for this talk will be available on my website, so you can check them out. But there are a ton of information out there. Security testing professionals, like testing professionals, share so much of their knowledge online. And the key to this is to practice. If you want to learn security testing, you practice. And the easiest way to do that is to take part in bug bounties, where you're actually given permission to look at live sites. And if you're lucky, you might get paid money for it, but it's hard, right? And it takes a lot of time. But you can practice on vulnerable applications. Now, the benefit is if you decide to learn more about security testing and practice it, none of that time will be wasted because it's the same techniques that you will apply when you go back and do your normal testing. When you are looking at live sites, you are learning about how other sites structure themselves. You are using your tools and techniques on them, so you are gaining more experience, exposure, more practice. None of this is wasted. It just takes time, and it can take a lot of time. And we don't know what we're going to get out of it because we're exploring, we're learning, we're experimenting. But when we are working on systems and our jobs, we need to figure out how to add more of this into our existing approach faster. But what does security mean, right? Because does it mean that we want a more secure system? Because testing may not give you a more secure system. Testing doesn't build quality in. Does it mean more job security? Chances are, if you want more job security, that means more flexibility in how you approach your work, more experience, more skills, and learning more about security can do that. Adding more tooling in such that you understand it can do that. We will gain more trust in our automated execution because we will probably use it for more things. It has to be more reliable. It has to be more robust. We can't extend our automated execution if it's flaky because it needs to be solid. We do stand a better chance of finding security issues early on, but it's still a risk. But security might mean all of these things. You might find that if I was someone else, I might be talking about shift left. And personally, I don't like the term shift left. I don't want to shift left, right? I just want to test. And I want to do that in a way that is best in a dev process where testing's enmeshed. And I do not want to shift right. I want a process that brings all the problems to light, right? Secure software is not a sound bite. Quality software is secure and it's built with foresight. I do have a book of children's poetry and it's available now from therearehats.com. So what makes testing hard? It's the same things that make security testing hard, right? All the unknowns. Where do we aim? Where do we stop? How much do we have to do? Is this going to find something if we continue down this path? I mean, this is why you get so much money for bug bounties because we don't know where the problems are. We don't know how long it will take to find. Now, security testers very often get lucky. They find a vulnerability, then they find a way to identify it, then they go and scan the web looking for those vulnerabilities and pick up bug bounties. But it's hard, it's expensive because it takes a lot of time. It's really important, but it's expensive in the same way that testing can be expensive if we do it inefficiently and ineffectively. And anything that we approach from the outside in with more unknowns is going to take longer and be more expensive. The easiest way to do this is to build it in. Very often from a testing perspective, we may not have access to the code, or we may not think about having access to the code, but building security in is the easiest way to cover this. In the same way that if you want to build a quality system, you build it in right at the coding process, the same as with security. It's very hard to say, are there any issues with SQL injection? But if we can say we have added coverage of SQL injection at the point where SQL injection can occur, if our coverage has been reviewed by AppSec, by the team that looks at the application security in our environments, if we have data generation in our tests, have we fuzzed it with common SQL injection payloads? These are very specific questions that we can answer, which is very different from have we tested it for SQL injection and have we tried to hack it this way, which is hard. When we build in and target specific risks, then it's a lot easier to then look at the gaps in our coverage and then start exploring that from an outside-in perspective. When we look at security testing, we should probably also consider some do's and don'ts. All right, so we must never reduce the security of our application to make it easier to test or easier to automate. So if we have CAPTCHAs in there, we do not build in ways of avoiding the CAPTCHA. We do not pick a CAPTCHA that is easy or possible to automate. We do not dumb this stuff down because it means that someone will take advantage of that in the real world. Ideally, our test environments should be internalized, but if we do externalize them, they need to be secure. Any unsecured test environment on a subdomain, test.mysite, whatever it is, can be found. And if we haven't taken all the appropriate steps to make it secure, it could be exploited. And people will raise bug bounties and security defects against test environments. Test environments can sometimes be so insecure that they leak information that allows people to then target the main application in more detail. Any vector that gives people more information can be used against us. So if our test environments are public, they need to be as secure as the external site. Now remember when we started with WebDriver and we were trying to use HTTPS, that was always a real pain in the olden days. Nowadays that's quite easy. WebDriver can handle HTTPS seamlessly. We don't have to worry about it. Therefore, we don't have to dumb things down anymore. The tools have got better and made it easier for us to stay as secure as possible. We don't have to dumb things down. Other things to consider are the risks associated with live testing. There's nothing wrong with testing in live, right? But we have to consider the risks. If we have test users in our main environment and they have more permissions than they need to have, then that could be a risk for us because test users might have easy to guess usernames and passwords, and because we're sharing them around in the team, we may not change the username and passwords very often. We may just leave these users lying around in the environment and not monitor them, not pay attention to what they're doing. But again, they could be a vector in that someone can take advantage of. If we're using security tests without knowing security testing, then we may not be able to interpret the results correctly. That may be what we have to do. That may be as far as we have to go in terms of learning security testing, is understanding the results of the tooling. Not necessarily knowing how to do security testing, but we do need to know how to interpret the results of any tooling that we add. So let's have a quick look at what tooling we might add to our existing testing and automating to help push us further into the security testing realm. Now, there are so many security testing tools out there. If you look at Kali Linux or anything that covers Kali Linux, there's a huge number of tools in there. But what we want are tools that don't sit separately, but that we can use as part of our process. So the easiest way to add tooling in is to keep everything that we already have, but push the execution through more tools. So we could start doing everything through a proxy. I use proxies, HTTP proxies all the time, like OWASP, Zap, Burp Suite. I use these all the time when I'm testing, and I add them into my automated execution for more information. Basically, my browser is configured to go through a proxy. The proxy is running. So when I run my automated execution, either API or GUI, all the requests that are made are being tracked in the proxy, which means that once I've finished, I can go and look at all the traffic that was put through. The tooling will build a sitemap for me, and I can look and see what coverage I achieved during that testing. I can spot gaps. I can see, or the tool will pick out URLs it's found in the HTML or the message requests that possibly I haven't hit, so I can see gaps in the coverage in the tool. And that's a benefit to me when I'm doing my normal functional testing, but the tool will also scan the requests. It will passively scan the requests that are made through there and potentially point out security issues. If we just blindly raise them all and say, oh, this cookie doesn't have HTTP set on it, and just blindly raise all these things, we're going to be causing noise in the process. We have to understand what the messages in the tooling are. One of the benefits of Zap is that it will passively scan in the background, but having done all our testing, having achieved a sitemap, we can then do an active scan. And Zap can then look at all the URLs we have used. It will scan them in more detail. It will pass in more variations in traffic and parameters than it would normally do, and it will attempt to security test our site for us. Zap can also use WebDriver, so it won't just use HTTP messages, it can bring the site up. Now, if we haven't achieved a lot of coverage with our automated execution yet because we're still building it up, if you ran your initial automated execution through Zap and then run an active scan, it will cause more load onto your site. It will traverse the site and scan it for you, which may give you some kind of accidental coverage. It may highlight some accidental issues as you're testing. If you ever want to generate load on your site as you do exploratory testing, adding proxy tools or web scanners in the background can generate load, and you can see if it slows down in any noticeable way. Right? There's lots of advantages when we start adding this. It's an easy proactive step to take to improve security, and it's a lot faster than learning to hack. Another thing that we can do, and this might be slightly more controversial, is not just learning how to code to automate, but learn the basics of secure coding with the languages and libraries that you're using. Right? Every language has specific gotchas related to different security vulnerabilities. There's different ways of protecting against SQL injection in some languages that are not in others. Most of the SQL injection vulnerabilities will be removed by using parameterized queries, but there's different ways of implementing them. But what we'll see is that one vulnerability in your code, right, can be taken advantage of in 100 different ways by hackers. But fixing it is in one change in possibly one part in your code. And if it isn't just one change in one part of your code, then it may suggest that you need to re-architect the application. Now, we don't have to learn a lot from a testing perspective to make a difference in secure coding, right? All we have to really learn, if we don't have access to code, is to understand some of the approaches that these issues enter into our code, and then ask questions. Are we using parameterized queries when we access the database? We can ask that question to the developers. If we are, then we probably don't ever need to do any scanning for SQL injection through the front end, because we've covered that risk at a lower level. If you compare with people to see the code and see how it works, that will give you more indication of how secure it is, how we have architected this system from a security perspective. Now, it doesn't mean that you have to learn AppSec and review the code in detail and review all the libraries. all you're doing is making a difference by removing some of the most basic and obvious issues. And static analysis tools can help with this. So the SonarCube tools, SemGrep might help. The Sensei plugin from Secure Code Warrior, which sits in the IDE, has some basic rule sets to scan for security testing. That only works in Java. The other tools work in multiple languages. But look for scanning tools that work for the languages that you are working with. And that doesn't mean you need code access, but if you pair with developers, you'll get that code access. Because if we learn to spot what causes the issues, if we learn the fundamentals, then it's a lot easier to fix what's going on. Okay, now, one of the interesting things I found from learning security testing, and I'm just going to pick one or possibly two examples here. There are techniques that are classed as vulnerabilities in security testing that we actually use in automating. So in security testing, there's a thing called IDOR, Insecure Direct Object References, which means that someone is directly accessing a part of our application that they are not allowed to access. We use direct object reference in our automating to make it faster. So we may log in through the front end in our GUI testing, and rather than clicking on the menu, clicking on this link here, clicking on this link here, clicking over here, typing something in, clicking that button, we might just go directly to a URL which is at the end of that path, a direct object reference. We're going directly into a deep link in our application. If we are doing that, and if we have an advanced automating approach, then chances are we are doing that because it's faster. Then we can extend those type of tests to check for insecure direct object reference. We log in, then go directly to certain parts of the application and make sure we do not have access. Then we are testing for insecure direct object reference. And that's simply a data-driven test with a list of URLs that we hit, some of which we'll be allowed to access, some of which we won't. We may find that if we've used parameterized automated execution, and hopefully we are, because some of our paths are the same regardless of the data, but we want to vary the data, so we will use data-driven tests to do that. We could fuzz those, so change the data that we're passing in and use the insecure payloads that are provided with fuzzing tools. Like OWASP's app has lists of files for fuzzing with SQL injection, JavaScript injection payloads. We could use those as test data to make sure that they are rejected by our application, a natural extension to our existing approach. Now we can also look at our existing automated testing with a security eye. So if we have an easy way of setting up users and permissions and data, and hopefully we do, because that's really painful when we're automating, is it secure? Do we have enough security controls around that? Or is it possible for anyone to create users, anyone to change the permissions? That would be bad. That would be insecure. Hopefully, the permissions that users have can be configured at a very granular level so that we have the principle of least privilege. If we don't have that, then it may be worth re-architecting because there may be security issues in there. We need to consider, when we have an advanced approach to automating, do we mix HTTP and graphical user interface testing? Hopefully we do, because it's faster. But are we then sharing cookies? Do we log in at one point, then share the cookies across all the different requests, inject them into the browser? If we do that and it works for everything, then we may be opening ourselves up to possibilities around cross-site scripting. We may want to investigate cross-site request forgery, tokens, which can make certain types of automating harder, but it just means we visit the page, pull out the token, then pass it through that way. And it may cut down on our ability to jump around the site more easily, but most of the requests don't require cross-site request forgery. It's just we can check whether we're implementing good practices as part of a review of our automation and testing. As a kind of summary, security testing is enormously fun and educational to learn, but it takes time. Now, there is a huge overlap between security testing, exploratory testing, and automating, as you would probably expect, because we're in the same domain. We're all exercising the application. We're all trying to explore it in different ways. We use the same tools. I used proxy tools before I learned security testing because proxy tools can add value to my functional testing. The more I learned about the proxy tools, the more I naturally learned about security testing to understand some of the results. And there was a natural growth and extension into my work that way. We can add those tools into our existing processes in different ways, and they can help our current process as well as extending us into the security realm. But fundamentally, everything that we do from the outside in is hard because there are so many unknowns, and it will always be useful to look at the actual code, understand the risks that are involved from the technology that's in place and the languages that are in place, and it's much easier to test for those and have longer running protection for those issues by adding them in as unit tests or integration tests around that particular area, particularly for something like SQL injection. If you have used parameterized queries and then think you're no longer vulnerable to SQL injection, then make sure that you add some SQL injection payloads around the parts of the application that use database access, just to make sure that no one later slips them in. Add more static analysis tooling into your build process to check for very simple errors. All of these things will help improve the security of the application. And as testers, we will then learn more, which means that we can extend our testing and use that knowledge in different ways. Now, fundamentally, security testing is a means to an end. For the end is that we want a secure system as cost efficiently and fast as we possibly can. Security testing may not be the best way to do that. Having testers learn security testing may not be the best way to do that, but we can augment what we're doing. We can extend our existing approach to automating and testing. The more that we learn about how the issues can be present in our application in the first place, the more we understand, the fewer unknowns there are, the more we can target those particular risks. But start by adding in proxy tools if you haven't already. Start by pushing the HTTP request that you make from the GUI testing and API testing through a proxy. See what functionality the proxy tool gives you in terms of building up a sitemap. Start gradually add it in. You may even find quick wins just by running static analysis against the code base. But there are ways to do this. I don't want to stop anyone learning security testing because it's such a fun way to learn, but it's not the fastest way to add more security into our application. So start experimenting with tools, see how you get on. It can be a quick win, and the benefit is you will learn more. All right, thanks very much. I think we're doing questions on the chat. If you want to, you can find me online. There's a bunch of content on my websites and YouTube and different places, and all the slides will be mentioned on these channels or from my website eventually. Thanks very much.